can't put it that way because the whole bar will be lying on the construction line. So if it's that way, we also have to allow for cover at the top, which is 50. So that length from there to there minus 50 is 2,500 minus 50. All right? So 2,500 minus 50 equals 2,450. So that is the length of that bar there, 2,450. The bar is straight, so we put S-T-R-A-I-G-H-T. Or we can put a line. The bar mark is 1602. We've also got a 1201, a 1603, and a 1604. So far, so good. The location of that bar is each face, because it's a wall. We're looking from this side, and it's one face, and it's also on the other face, so it's each face. Each face. The number of bars, well, they start here and they go all the way along the wall, which is 5 meters in length. Up the top, 5 meters. 5 meters minus cover, minus cover. So 5 meters minus 50 minus 50. 5 meters minus 50 minus 50 equals 2,400. So this 2,400 equals, sorry, 4,900. The bar spacing is 300. See, it says all centers equals 300 up the top. So it's 400, 900 divided by 300. Does anyone have a calculator? 16.33. So is that going to be 16 bars or 17 bars?
17.
No.
17 space.
It's 17 gaps.
17 gaps, then 18 bars.
18 bars. No. Times 2. 36 bars. Why times 2? Because there's 2 of them. So there's 2 of them. They go for 5 meters. We've worked out, because of Max at the back, we've worked out that there is 17 spaces, which means 18 bars. So 17 spaces equals 18 bars times 2 equals 36 bars.
That is always rounded up. Hey Roger, sorry.
Yeah.
Yeah.
So there is a rule, and we're going to come across it shortly. If that was 0.1999, then it goes down. If it was 0.2000, it goes up. So it's more than 0.2, so we go up to the next number. If it was 0.1999 or less, we would go down. Okay? That's what I call the 20% rule, or the 0.2 rule. Okay, so there is 36 bars, so the 36 bars go there. And the weight is so they're D16s, so the weight is 1.578. 1.578. Now, at the end we'll tally this up, but basically that times that times that equals 800. 1603. Okay, so the 1603 bar is this one here. It's a U bar, and you'll notice that there's one goes like that and one goes like that. Now I'm going to draw a sketch over here of what that actually is, because when you look at that sketch, you think oh, the bar goes like this, and then the next bar goes like that, right? That's what that sketch kind of tells us, isn't it? Right? One bar goes like that and the other bar goes like that. No. what it is actually, if I was to draw it properly, one bar goes like that, and the other one at the bottom comes along and goes in behind it, like that. That one there goes down to there. When we're doing reinforcing, we always push it right up against the cover. Okay, so one is behind the other. Not like the sketch. The sketch is only to show you that there's two bars. If I did the sketch one behind the other, the sketch would have looked like this. Then you wouldn't know what's going on. Right? If I did it properly, it would be like that. And you'd be like, huh? Is that what sort of bar is that? So what I do, and what all engineers do on the sketch, is they always do that to show a little bit of separation, but you know that one is behind the other. And I told the diplomas the old grandma quilting thing. When grandma did quilts, she always went right to the edge for the strength. It's the same with reinforcing, it's the same with plate design as well. We always put the bolts as close as we can to the edge to give it the best strength. So, coming back to here, we have a U-shaped bar, and we'll start to draw a sketch of it. The U-shaped bar is going to be 400 minus 50 minus 50. That's easy, 300 on both sides. That distance there is going to be 2 meters minus 50 minus 50. 1 meter 900. But the problem is we can't bend a bar so that it looks like this. We have to bend the bar so it's got a curve on it. Right? Even the strongest man in the world can't go and it's at right angles. If the strongest man in the world went like that, it would be a nice curve on it. There is a minimum curve and it's relative to the radius. Up here, that's the curve when we draw it, but this here is what we subtract from the overall length. So this is a D16, so we subtract 36 for every bend. How many bends? 1, 2. 36 minus 36 minus. The calculation to find out the total length is 300 plus 1900 plus 300 minus 36 minus 36 equals. I need someone to give me that, please.
2428.
2428. And how many of them are there? Well, we've already done that calculation for the bar above. Exactly the same calculation. 5 meters minus 50 minus 50 divided by 300 equals 16.33. So we go up 17 spaces, 18 bars, 36. And because there's a U-shaped one that way and that way, you multiply it by 2, which gives us 36. So that's easy, 36. It's on the slab, so it's top and bottom, so we call that T and B. The weight's still the same, and we can total those numbers up later on. 1604. 1604 is this one here. The width of that's easy. It's 400 minus 50 minus 50. So the bar looks like this. The width is 300. The height is going to be equal to 300 plus 400 plus 100 plus the lap minus cover at the bottom. 300 and 400, 700, 800, 800 plus 520, 800 plus 520 minus 50. 800, 800 plus 520 minus 50 equals 1270. So it's 1270 here, and it's 1270 on the other side, but we haven't finished yet
What about the bins?
because we've got the bends of 36 up there. So we've got to take 36 off here, and we're going to take 36 off here. So the calculation for that is going to be equal to 1270 plus 1270 plus 300 minus 36 minus 36 minus that's it. Oh, no, that's it. So it's 1270 plus 1270 plus 300 minus 36 minus 36 equals
2768.
2768. 1.578. How many of them? Well, actually, it's the same calculation, but this time there's only 18, because there's not two of them, there's only one of them, right? So that's 18. Where are they? Well, they're actually top and bottom and each face. So that's quite a strange one. T and B, E, F. Lastly, the last one. The last one I'm going to have to do on the board over here. Or maybe not. The bottom, we divide it into three areas. A, B, and C. All right. Now the hardest one to do is B. A's not too bad. A is going to be 2,500 minus the cover, because you can't put it on the construction line joint. So that's going to be 2,400 divided by 8. That's easy. That's by 300. It's 8 gaps, 9 bars. All right, 9 on one side, 9 on the other, 18 altogether. So if we were to look at that in terms of doing it like this, we have the top one, and we just worked out that there were 9 on that side and 9 on that side, so that makes 18. We'll put 18 there. Now this one here, and that's the hardest one to work out of them all. And you're going to need this because you're going to be doing that similar in your assignment. So remember, the bars come round, curve round there, and they curve round that way, right? So if I was to blow that up, it would look like this. And this bar comes along and up like that. The donuts start cover and 3 times the diameter at each end. The other end, it starts the cover as well and 3 times the diameter. Let me explain that just with the example answer, and you'll see it a bit better. If I can. here. 9. I'll make an example answer available. It's not Jim, here we are. So, week 9, example answer 1. It's available now, the model answer. If you have a look at this bar here, you'll see that A is exactly like I said, it's 2,500, or is it 200 in height? What's the height? Oh, it's 2,400, sorry. 2,500 minus cover is 2,400 minus divided by 300 equals 8 gaps. 8 gaps is 9 bars, 9 times 2 is 18 like we got there. The next one, the bars are like this, and it is a diameter and 2 diameters, that makes 3 diameters, plus the cover at each end. So when calculating it, it is as follows: 2 meters wide minus 100 equals 1900, minus 3 times the diameter at one end, minus 3 times the diameter at the other end, equals 1804. 1804 divided by 300 equals 6 gaps, but it's not 6, it's 6.01. Using the rule, it goes to 6, it stays at 6. Therefore, applying the 0.2 rule, it stays at 6, so that's 6 gaps. The 7 bars equals 14 because there's one on one side, there's one at the top and one at the bottom. So 14 bars altogether. So section A was 18, section B was 14, section C is, you can only get one lot of bars in there. So it's 18 plus 14 plus 2 equals 34 bars. The bar length itself is the whole length of the wall minus the cover, so 4,900. The number of is 34, and that is going to be each face, top and bottom. So all we need to do to complete this chart is to multiply everything out. The weight there is 0.8 something. And does anybody know what we would have done if we had a 12 bar overlapping with a 16 bar?
Would you add them together and then divide the?
No, which lap do we take? Do we take the bigger one or the smaller lap? We've got a 12 bar and a 16 bar.
Take the bigger one.
He bet you by a fraction. He's got himself half a mark. He'd never had a half a mark, have you? Christmas. You know the rule? There's two ways of doing this. You can do what Lance did and forget about emailing me and hope that I'm a good guy. He hasn't got a mark so far. Or you can email me before midnight tonight and you'll get your half mark. I know what I would do. Yeah. And if you get an email back from me saying, I'm sorry, this email address doesn't exist, that's just me joking, okay? All right, so the model answer has got everything at the bottom of it. It should have. So that goes through everything I've just been saying, but you can go through that in your own time with the allowances and everything, and it's got a example answer here, which should mirror mine. The numbers are 14.27. $147. 147.27, 139.18, 137.97, 93, and finally 78.62. Gives a grand total of
503.
503, which is very different than 501. You can ask anybody at the airport that. There we are. Okay. Oh, sorry. This one up here is a straight bar as well. So that's an example of 4 bars, and that's what you've got to do for 5 marks in your assignment. You've got to do 5 bars, I think it is. You'll find 2 or 3 of them are very, very easy, and 2 or 3 of them, a couple of them will be quite tricky, and what you might call golden marks. All right. There are a couple of bonus marks tied up in the assignment. Now, to help you even more,
Sorry, what's the EW means? Because on
each way.
each way. Oh, like that.
Yeah, that's another way of saying each face. It's, yeah, each way, each face. Yeah, I would say each EF is probably a little bit more correct. I didn't do the model answer for this. I would call it EF if it was me. Just going back to, I will have to get going in a couple of seconds, but just going back to week 9, there's another example there, example 2. I've already shown you that, but I'll show you that with the answer. So what this is a water race, which is shaped in a U shape, which isn't that dissimilar to your assignment. Your assignment is in a U shape, but it's upside down to that. This gives a lot of different things to reinforcing. It's meant as a general help to students for all reinforcing. In this case, there's a minimum bar length, so they have to chop the bar and make it overlap. In this case, there's also a bar that doesn't tie on to the other bars, so we have to change the spacing to make it tie on. It's got everything else, and it goes through one by one, telling the answer, both calculating the concrete volumes and then going through with little sketches showing how to calculate the bar. There we are, there's that one with the diameters on it. So it's another example, another perspective, and another bar schedule, okay? So there's 2 examples you've got now with answers. I've gone through one in class. You've got one to do as your assignment. And it really is one of those things that you need to have a go at it yourself and come in here and meet someone and your friends or whatever and have a real good argument about it and find out who's right and who's wrong. There are model answers to different assignments on the past of mine. I tend to change a little bit each time, so be very careful of that. If you come across one, someone thinks they've got gold, but might not, just it might be the gold that shoots them in the foot. But you do, if you do have a past example, it's really good to go over that as well. And of course, you're going to need to be drawing this up in a plan view as well. So really, 10 marks out of 30 is all tied up with the reinforcement. And then if you're not that confident, have a crack at the quantities. Next week we'll be doing steel, so you'll be able to get on with doing the steel quantities as well. my suggestion is that that 3rd of November is gonna creep up on you and hit you real quickly. And you don't wanna be leaving a 30-mark assignment to the last minute. I mean, some of my 15-mark assignments were hard enough to finish, even if you did start them early. Remember, start a new drawing, the title block, use the title block and the logo that I'll put there. It's still an A1 drawing, you still use A1 full bleed, and the scale is 1:20. Oh, one parting thought, the text is different. With the text for the civil, you multiplied it by the scale, then divided it by 1,000, right? So it was 3.5 times the scale of 1 to 100, then divided by, this text height is still 3.5, but it's easy, there's no divided by 1,000, so it's 3.5 times 20 equals 70. Okay, 3.5 times 20 equals 70. I'll leave you with that. You're welcome to email me if you want to through the course of the week. Just remember that, like